So when we get here, now we're talking about accelerating. I kind of let the cat out of the bag already. So what we're looking at here is, I know you all want to see my running man. There's my running man. He looks like he's getting ready to fall, but he's actually running. Somebody once told me that running is actually falling while catching yourself. So that's what he's doing. He's falling while catching himself, which we can call running itself. So now if I'm speeding up in this direction, I'm speeding up, my acceleration is there, then I just have to show a larger force of gravity on the runner by the earth, the force normal on the runner by the track, the force applied on the runner by the track, and the force of friction on the runner by the track. And then we come back and do the force diagram for the track. We still have that, yay, FG on the track by the earth. This one, which is FW on the track by the runner, so that's still there. The upward arrow, FN, on the track by the surface, or the ground. And now this one needs to become still the same size. The track's still not going anywhere, so it does not change. Force of friction on the track by the ground, and the force applied on the track by the runner. So once again, we have that force pair here. And yes, we still have that force pair here and there as well. So you see what's happening here. We have these two here that are keep flipping places. So this one tells us that the runner is accelerating. Nothing is happening to the track right here because it's in equilibrium. We know the track doesn't move. And we'll go to our last situation where the runner is slowing down. So the same thing would be happening if I were being to draw this. My runner would still look kind of like this, okay, except I would know that my acceleration is in this direction against his motion. So what we're looking at here as far as force diagrams goes, now I need to show that that force diagram is greater in that direction. So I need to show that net force there. So I still have force of gravity on the runner by the earth. I still have force normal on the runner by the track. And now this force, it can be the same or it can get smaller. It probably should be this. It probably should stay the same. So let me go back and look and see how I drew it. Let's draw it just here. And then if I want to, the force of friction on the runner by the track, and then this one just needs to be smaller. Force applied on the runner by the track forward. So because we're dealing with pushes, these all end up being the same way. Here in just a second, I'll do one more, and I'll show you what happens if we're maybe a cart that is pulling. I got that FG on the track by the earth. And I have, you see I'm stacking the arrows to keep them size-wise, so I can keep track of my sizes. On the track by the runner. Then I got that same upward on the track by the runner. And now I'm going to have a smaller here, so the track only needs a smaller force too to keep it moving. That's the force applied on the track by the runner. So we're still ending up in the same situation. We really hadn't changed anything here. We're still, this is still a force pair, and this is still a force pair here and there. So let's cover one more situation here, and they get kind of redundant with just looking at different situations. Let's look at one more situation, and I don't really want this, so I'm going to delete that, and let's look at what happens if something is pulling. So let's say I have a guy standing. Let's make it green for the grass. Green grass. Green grass. Here's the grass. I know my drawings are becoming more sophisticated. Can't draw black people on here, so I'm going to draw white people. And let's say I am now pulling. And I got another person over here that is, whoa, pulling. And let's put a rope between them, and let's use a blue, nice blue rope between the two. Now I'm going to draw a force diagram for each one. I'm going to draw a force diagram for object 1 or person 1, and then one for person 2. And we'll say that he has a 50 kilogram mass and he has a 100 kilogram mass. So what we have here is I have this one that's going to have Fg on 1 by the earth. Then I'm going to have that same Fn on 1 by the ground. And then this person is actually being pulled in that direction. Force applied on 1 by 2. And then in this direction, I have the force of friction on 2 by the ground. Now come over here and flip it to this person. The next person over here, we're going to use purple. Have the same, now it's 100 kilograms, so I just need to show a larger Fg on 2 by the earth. Fn on 2 by the ground. And then this person is still pulling me this way. That's the force applied on 2 by 1. Force of friction on 2 by the ground. So if I'm identifying my force pairs, here they are. I have no other force pairs here. Now let's do one more. Uh-oh, I have apologize for the length of this video. Sometimes we just have to get it covered. So I have, now we're going to push on one another. So we have the same grass. Here's some more grass. And now the people are going to push. 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 And they're going to push on one another. So now student, or person 1 is going to push on person 2. So we're going to do this real quick. Same thing. They got 50 kilograms and 100 kilograms. Try to wrap this up quickly. And here I have Fg on 1 by the earth. And I have Fn on 1 by the ground. Now this person is pushing in this direction. That would be the force applied on 1 by 2. And now this one becomes opposing. Force of friction on 1 by the ground. And red. It's time for red. Got to be longer. I have no idea why my lines go diagonal. I try to keep them. headed in the right direction, but sometimes it just doesn't seem to want to work. That should be vertical on 2 by the ground. And then now I have, in this direction, this time, I have the force applied on 2 by 1 and the force of friction on 2 by the ground. And now my force pairs again, my force pairs are here and there. So I hope this helps, and see if you can help do these on your homework, and we will be prepared to answer any questions about these tomorrow. And I hope you have a good evening, and until next time, happy physicsing.